Okay, so I was just working on coding out the linear regression part. Just practicing some algorithms just to clear out the concepts. I coded the linear regression function, the cost function, and the gradient, computing the gradients. Now I'll just code out the updation of the gradients so that yeah, I'll just do that here. Before that, let me just write down the steps that I'll be doing so that there will be some clarity. So, step 1, I'll be computing the cost. Then, step 2, update the weights. Step 3, I will update cost. Okay. So here what inputs will be the input, the output, the original output, then the learning rate and epochs. Then we have then we'll have the image epochs, the biases, weights and biases, and the B input. Then we'll look into it later. Okay, so I'll just initialize the cost array. Here basically I'll just keep a track of the costs that I'm getting and just look into it later. And then for I in range, I'll first get the costs t2 db and x comma yes, and then basically update it. Goes to dj learning rate to dj. Okay, and I don't want to alter the input rate, so that the w in does not change. JavaScript. bname is equals to dgut, and then sorry, this will be gradient. So now I'll compute the cost. X comma y comma b, and then cost. So we've done the updation of the weights, and we've done the tracking in this step. So now just we'll return it. Return the cost track, then the w comma b. Also I'll do one more thing, just for monitoring purpose. Let's keep it this way. Okay. Now we'll just see how this works. So I'll not create a huge data. This will test out the function. And create out 1 comma 2. Keep it keeping it that way, and we'll need the learning rate. Let me keep it 0.001. We will have the epochs. Let's keep it 100, and then we'll have the weights. We can initialize the weights through a lot of process, but let's do it this way only now, because our main focus in testing this the weight updation process, the gradient descent basically. I think this is all we need. Yes. Cost track we pass the epochs, and w comma b. Okay, we have it. Now should we plot it? Here there are two there are two costs. How is that possible? So I'm getting two costs here. So this is coming as an array. But why? Getting the shape and getting basically the number of rows, and for each row I calculate the predicted value. Okay, and then for the predicted value I calculate the cost here, and this is the formula. Got it. So what I missed here is that I am just like in this step I'm picking that particular row's input value and then creating it. But while computing the cost, I was passing the entire array for computing the cost. So basically, that's the reason now it should work possibly. Let's see. Yeah, good. Now I should plot it. Cost. Let's do this. Yeah, I'm a bit poor at matplotlib and all. Yes. I don't want to waste time on it. So let's see it once. So you can see it's decreasing. It's almost linear. Just here it's not linear. Yes, this is how basically you can come up by just coding out the solution so that you can understand basically what's happening inside. Yes, and also I think this way you can improve your numpy skills and basically Python skills too. Yes. So I'll be coding more machine learning algorithms, and I'll keep you guys posted. Okay, thanks.